Okay, we're now going to start with geometric sequences. Before we go into geometric sequences, let's just refresh what an arithmetic sequence was. An arithmetic sequence is by adding by a constant difference d. Right? So that was in the sequence, every number in the sequence had a constant difference d between them. But now a geometric sequence is multiplying by again constant ratio r. So every number in the sequence is multiplied by a constant ratio. Let's do an example. It always helps to understand these things better. I'll give you 5 rand and I'll ask you to double it every day. How will this look? I say day 1, 2, 3 to n down the left hand side. On the first day we'll have 5 rand. On the second day we'll have 10 rand, and 10 rand is the same as 5 times 2, which is the same as 5 times 2 to the power of 1, because we know that 2 to the power of 1 is equal to 2. Then on day 3 we have doubled the 10 rand to get 20 rand. We know this is the equivalent of 5 times 2 times 2, and that's again 5 times 2 squared. We can see a bit of a pattern emerging here. Day 4 we now have 40 rand. We doubled to 20. 5 times 2 times 2 times 2, and that's 5 to the power of times 2 to the power of 3. Our pattern is coming along here. Let's have a look at n. 5 times 2 times 2 times 2 times 2, all the way, and that is equal to 5 times 2 times n to the negative 1. Why n to the negative 1? As we can see, for day n, which was 4 over here, we can see that this was 3 over here. And the similar, for 2 over here, we can see 1. So this was always 1 less. So this is n over here, and we can see that that is n minus 1. So we have a bit of a general formula emerging. Another thing to note is that the ratio was always the same. The ratio between T2 and T1, which is 10 and 5, was always 2. The ratio between T3 and T2 was always the same. And this ratio of 2 can be seen throughout. And this will go all the way to Tn and to Tn minus 1. And that is the constant ratio we talk about. Let's have a look. We remember our terms, term 1 to n. Let's have a look at the general formula that is starting to emerge. On day 1, we had A amounts of rand. So this was our first constant formula. On day 2, we had A times the ratio. On day 3, we had A times that ratio times that ratio. And this kept on going down till it was A times that ratio n minus 1 times. So what does this start to look like? Imagine we had A to the ratio to the power of 0. What is R to the power of 0? We know that R to the power of 0 goes to 1. So that's just A. Then we have A to the R1, A to the R2, A to the R3, all the way to A to the R n minus 1. And right over here, we have finally got our general formula. And here it is. Tn is equal to A r n minus 1. And this is for every term n. The general formula for the geometric sequence is A to the r n minus 1. And now we can fill it in. Our geometric sequence, our formula, is Tn equals A to the r n minus 1.